Hello. In this video, we talk about the frequency and what is the frequency and behavior of different components that we had in previous videos, resistor, inductor, and capacitor during the changing of the frequency. So first, what is the frequency? The frequency is only for AC system, and for DC system, the frequency is 0. So the frequency is the oscillations, the number of oscillations during 1 second. So when we have frequency of the 50 hertz, you say that, or 60 hertz, for example, here, frequency of 60 hertz, you say that, okay, we have 60 oscillations or 60 repeat of one sine wave until here. This one sine is complete to the end of 1 second. So for example, for frequency of the 50 hertz, every 20 millisecond, 1 divided by 20, every 20 millisecond, we have one repeat. So the frequency is inverse of the time and is repeat of one sine wave. Start from 0, then go from 0 again and again and again. So if we divide 1 divided by frequency or y divided by time, we can find each other. So 1 divided by 50 will be time. For each repeat, it will be 20 milliseconds. And if we change the frequency, for example, if we increase or decrease the frequency, if we increase the frequency, the number of repeat will increase. So this is higher frequency, a lot of repeats, and the low frequency is only 1 or 2 repeats or time. And for AC systems, if we want to write the equation for AC sine wave, this is the normal equation. Here is a domain or maximum value. This is the frequency, omega. Omega is 2 pi f is omega. And t is the time. So if t is 0, the sign will be 0, so whole will be 0. If this is the maximum value, the sign will be 1, then the maximum value will be am maximum. Then it go to negative and go to 0 again. Here we have phase. It can be positive or negative, so it can be plus 30 degree or minus 30 degree, for example. If you have plus some phi, plus 10, plus 20, something, this curve will shift to left. It will do something like this. So at the 0 second, it will be some value. If this is negative, this curve will shift on right. So every component have different behavior during of different frequency. Resistor is independent to frequency, so if the frequency is DC, AC, changing high or low, the frequency is more or less constant value. But the inductors and capacitors will change during of changing the frequency. So we have a concept as a impedance, and we can more or less find the impact of each component, inductor or capacitor, and the behavior same to a resistor by equivalent to a one to impedance. So impedance is Z, and the unit is ohm, like the resistor, and resistor is independent to frequency, but capacitor and inductor are depend on frequency. So for capacitor, the capacitor behavior, the capacitor value will change by different frequency. So if we have a DC system, if we don't have any frequency, then the impedance or the behavior of the capacitor, it will be something like an open circuit. So it say that, okay, we have infinite frequency, infinite resistance. If we have the frequency of very, very high value, couple of kilohertz, megahertz, then the capacitor will be something like a short circuit. So if we want to equivalent for the circuit analysis, a capacitor to impedance or reactance, the value will be something like this: 1 divided by 2 pi fc, or 1 divided by omega c. This is the value of the impedance. And this is an example. If, for example, we have a capacitor of 220 nanofarad, and the frequency is one time is 1 kilohertz and another time is 20 kilohertz. In 1 kilohertz, the reactance or ohm value is 1 divided by 2 pi fc. For 1 kilohertz, it will be 723. For 20 kilohertz, it will be 36 ohm. So we can see the difference here. So the capacitance will change like this: frequency higher, the reactance go lower. So when the frequency is 0, the capacitor is acting like this. When frequency is very high, the capacitance like this, short circuit. So this is the reactance that we have. If we want to find how much is the voltage, because you know that we had some Ohm law, if we divide the voltage to the resistor or here to reactance, we can find the current. So this division will change the current something like this. So the value of Z or reactance will decrease, uh, we can find the current something like this: V divided by Z. So here we have one resistor and one capacitor together. If we have both of them together, then the value of the impedance can be found by the summation of these two values in this way. So something like this. So reactance power 2 plus resistance power 2, it will be the impedance. So V divided by this value, we can find I. For inductor is also the same. For inductor, we have the reactance and the value is 2pfL, and is exactly inverse of the capacitor. So by increasing the frequency, this value will go higher and higher. So by increasing the frequency, the value go higher and higher, the current will go lower and lower. So for DC, is short circuit, for AC is open circuit. And if we have R and L together, as mentioned before, we can find I like this. So if we don't have L, it will be same as before, V divided by R. But if we have L, it will be something like this.